Now, the next step of this will be laying of sewers. Okay, so for the laying of sewers to be there, we need to understand few basic steps. Okay, so we'll go through that. First is this sewers will be laid from starting from the outfall end to the starting end. Okay, so outfall end will be at the lowest elevation, the lowest most elevation, and the starting point will be at the highest elevation. So based on that, you are going to decide the slope of that particular sewerage lines. Next, manholes are required to be constructed. So why manholes are required? The reason being, the manholes can do two things. Okay, so let us say this is a scenario. Okay, there is a house here, imagine. Okay, and this is the ground level which is there. Okay, now whenever I want to imagine I have taken this outlet of this sewer line over here, and I want to put the outfall sewer which is at this elevation. So at that point of time, what will happen? I need to go on digging and I need to join this here. So at that point of time, here the depth of cutting will be too huge, and it will be uneconomical and impractical also. So at that point of time, what I prefer is, instead of having this kind of depth to be excavated, so I'll make these manholes. So manholes, what they do, you can have its depth. Okay, so where I'm going to provide a lenient slope over here. Imagine I have just done this. Okay, so here the depth of cutting will be less, so I'll add this sewage into this what I can say manhole, and from there again at a lower elevation I'll take this outlet, and again I'm going to join it to the outfall sewer. So at this point of time, what will happen? The quantum of cutting is going to get reduced. Okay, so this is just a simple example. Okay, the here also right now in this example it may look like the cutting is more, but if the ground conditions are different, okay, basically at that point of time these things are going to work out. So manholes, ultimately what I am trying to express here is, manholes are used to connect two sewer lines which are of at different elevation. Okay, so manholes are used to connect two or more sewer lines of different capacities to meet at a single point, and but at right now they are at a different elevation. So for that we usually use the manholes. And even for a sanitary pipeline system that needs to be evaluated, so manholes are one of the most significant aspect of those. Next is, line is done between two manholes. That is, basically what you are trying to do is to minimize the amount of cutting of the particular, for the laying of these pipelines. You basically construct these manholes at a respective length. Okay, and you try to connect one manhole with the another manhole with the n number of sewer connections. So this is how basically you continue with the sewer laying work. Next, we have map showing all the roads, cable lines, lanes, etc. is prepared. So for a master plan or for that execution of that work to be there, so we need to make sure that all the roads and cable lines, so if any other cables are already placed beneath the ground, so all those things should be available to you. Pipeline with size and length should be marked, so that we can have an appropriate idea of where what kind of diameter of pipe is going to come, along with even the slope at which it is going to be laid. Next, the position of existing pipelines, curb lines, water line will also be marked. That is, you need to have a proper control over the existing status of that particular layout. Along with that, how you are going to even put your particular sewer lines will also be marked over there. Center line and offset line marking. So the first step of laying of sewer is with respect to center line and offset line marking. Center line of a sewer is marked by drawing an offset line on the ground parallel to the center line at a suitable fixed horizontal distance, that is 2 to 3 meters. Offset distance, usually it will be is equals to half of the trench width plus 0.6 meters. This offset line should be drawn on that side of the trench which is not likely to be disturbed by the piling of the excavated earth. Okay. Offset is used to find the center line by offsetting the fixed distance from offset line. Temporary benchmarks along the offset line at intervals of 200 to 300 meters should also be established by carrying the levels from GTS benchmark. So here, even in the next slide, we are going to see the figure where the things are going to get much more clearer. But here, if you check out, the center line usually will be marked by drawing an offset line, because wherever you want to dig that trench, right? So practically, whenever you try to dig it, so that line will go. Okay, so that's why we have a what I can say, a side by offset line. So with a reference to that, we are going to dig up the trench, and usually that offsetting distance will be of 0.5 into trench width, that is the width of the trench, half of that, plus 0.6 meters. And usually in the third point, what it has been shown is, on one side we can put the excavated soil, and on the other side we can have that offset line set up. Okay, and even the offset used by the center line by offsetting the fixed distance from the offset line. So that only we can have that offset line as a reference, and based on which the excavation can be done with the for the trenches. Okay, and even the temporary benchmark should be made for every 200 to 300 meters, so that the level at which the pipeline should be laid, even that is going to be an important part. So how much to dig up, that can be have a reference point by these benchmarks. Okay, now in the next slide, let us check out the figure. You can check this out. So here we have, this is the plan basically. Okay, so this is nothing but the trench width. Okay, this is nothing but the trench width which is there. You can check out, this is the trench width. Now this is the center line of the sewer, okay, in plan, and this is nothing but the offset line. Okay, now you can check out, on one side they have put up the soil, excavated soil. Okay, this is what is being excavated. This entire section is being what, excavated over here. Fine, so this excavated soil is being put up on this side. Okay, and for this reference, this center line which is there, okay, so we have this offset line created. This dotted line is nothing but the offset line, and offset line is at what distance? It is half the trench width, that is 0.5 into the width of the entire trench, half of that trench width plus 0.6 meters. So this is going to be how much? 0.6 meters. So this is how your particular center line and offset line marking will be there. And you can check out, these are nothing but the pegs, intervals at 15 meters or so. So to make sure that for a reference basically, right? So you cannot just put a line on the ground and you forget it. No, basically you need to have some temporary fixtures that needs to be placed over there, so that that particular alignment needs to be maintained for excavation work. And one more thing that has been discussed is with respect to the levels. Okay, so for all these particular offset line, the levels will be marked up. Okay, and as and when that RL is going to be there, so based on that, that much amount of depth needs to be excavated over here. In simple terms, if I need to explain, imagine, okay, imagine, yeah, fine, so this is the entire length which is there. Okay, so whenever I consider the elevation or the bottom of this sewer line at this section, okay, if I just try to draw the section over here, okay, so this will be at a higher elevation, yeah, and if I take a section over here, this will be at a lower elevation. So at that point of time, you can check out, so my section will be something like this. My section will be something like this. So here I need to have less depth of excavation, here is less, and here it will be more. Okay, and to assess this, how much depth needs to be there, so that's why we need to mark up the RL or levels of these particular sewer lines on these offset. So why we are trying to maintain this offset so carefully is because whenever we try to dig up something over here, entire thing will be disturbed. So whenever you excavate, this particular center line will not at all be visible to you, because you have excavated that part. So that's why this center line will always be with respect to the offset line, which is not disturbed during this excavation process. Okay, So this is the first part of laying your sewers, that is marking of center line and offset line. Now the next part is with respect to the trenching or else trenches. Okay, so for these particular trenches, you can check out the road pavements may have to be first of all removed. Okay, softer pavements pickaxe or by manual labor, and hard concrete pavements with pneumatic drills and spades. Okay, here you can check out. You need to dig up, so that is nothing but the trench. First you have marked out everything. Now the next step is going to be putting the trenches. Now if it is a soft pavement, that is directly the muram pavement which is there, non-paved pavement, so then manual labor can be used for the excavation of that. But if it is a paved or a hard concrete one, then pneumatic drills or any spades that can be used for the excavation purpose. The inner portion is removed either by pickaxe or power shovels or boom and bucket excavator. That is inner portion in the sense what? Whatever these pavements will be there, that will be there only on top of those surfaces. Okay. After the depth of that particular pavement, again on bottom we have the soil or any gravel, the same things are going to be there. So the next excavation, the next layer of excavation will be done by pickaxe or power shovels. Minimum width of the trench should be is equals to 15 centimeters more than the diameter of the sewer. So if I want to fix up or else lay the diameter of sewer of 100 centimeters, then we need to make sure that the width of that particular trench that we are making is 15 centimeters more than the diameter of that pipeline. And for smaller pipes, usually the diameter smaller pipes, these particular this width of the trench can be 60 to 75% centimeters more than that. The reason, because as and when the depth of excavation increases, so you require a few space for a person to stand there and lay there properly, and even help him to joint the things, right? So join one pipe with the another one. So that's why for smaller diameter pipes, the offset or else the width required is much higher than the larger pipes. Okay, pipes in firm ground, no need of embedding of concrete, and the bottom half portion of the trench is excavated as the shape of the pipe. So here you check out pipes in firm ground, where the ground is having more strength, okay, bearing capacity, then no need of embedding the concrete, and the bottom of half portion of the trench is excavated as the shape of the pipe itself. So here instead of putting a one more layer, so in cast in C2 if you are trying to cast it, so such kind of things will be helpful. Pipes in softer or ordinary ground needs embedding of concrete. So if it is a soft one, then we need to have a bed concrete or a preliminary layer of concrete to go ahead with that. The recess is also excavated at the required interval for accommodation of joints and caulking at the bottom. So recess in the sense what, whenever it comes to the joint part, where even you need to join the bottom half portion. If I take the conventional circular one, okay, so jointing needs to be there even for the bottom part. Okay, so that's why here the excavation at these recess points should be a bit more, so that your particular apparatuses or your the person who is standing here can reach all around this particular section to provide proper jointing work. So that is what is meant by the last point. Now let us check out the figure for understanding these trenches in a much better way. Okay, you can check this out now everyone. So yeah, so this is the excavation of trench for laying sewers. Okay, so this is the center line. So right now it is nothing but the section. So in the last figure what we saw was the plan. Okay, so this is the center line, you can see this is the trench. So this is nothing but the pile, and this is the offset line. So at this point of time you can check out, so offset line marking will be what, half the trench width plus 0.6 meter or 60 centimeters. So this is where your offset line is visible, and this is the center line of the sewer. Okay, now you can check out, this is the depth of that particular trench that has been excavated over here. Okay, and similarly on one side if we have the offset line, on the other side we have the excavated soil. So whatever is being excavated out of this is taken out and placed over here, and even the distance for this that needs to be maintained is what, 0.6 meters or 60 centimeters. Now having that in mind, next thing that needs to be concentrated here is regarding the pipes. Okay, you can check out here. So bedding concrete, so if the soil is soft over here, then the bed concrete is required at the bottom. Okay, plus you can see 7.5 centimeter here, 7.5 centimeter here. If it is of a larger shape, then this much space is enough for the jointing or any other connections that needs to be done over here. Okay, so basically what, the trench width should be what, 15 centimeter, usually more than the diameter of the pipeline that will be there. And this is indicating what, sides of the trench may be vertical for smaller depths and are supported inside by a timber or a larger for larger depth. Okay, so even in the coming slides we are going to check out. So if the depth is small, then directly vertical faces can be adopted, but if the depth is more, if vertical faces are adopting, what will happen, there is a chance of this soil getting collapsed on this particular trench. Okay, so that's why we can provide two things. One is we can provide some bracings over here so that the soil will not get collapsed on this trench, or instead of having this vertical section, we can provide what I can say, a trapezoidal section of cut where this will be in a sloped manner. So even here the chance of getting this soil onto this trench will be much less. So these are the two ways with which we can avoid that. So even in the next slide we are going to study with respect to that. So this is with respect to the trenches or digging that we are going to do. Now, next one is the part is timbering. Okay, timbering is nothing but providing the braces for that excavated depth or a trench, so that we can have safety for the workers who are working there. Okay, so it is used when the excavation is more than 2 meters, the depth of excavation is more than 2 meters, and is usual, and it is used to resist soil from falling into the trench. So as I have explained in the previous slide, the sheeting or sheetering boards are the wooden planks which are placed in actual contact with the trench sides, either horizontally or vertically. Okay, the sheeting or sheeting boards are wooden planks. These are nothing but the wooden planks which are placed in actual contact with the trench sides, either horizontally or vertically. The braces are the cross wooden pieces extending from one side of the trench to the another side, and may also be called struts. Uh, these braces are also called as struts based on the places where they are used. The ranger or wallers are the timber planks which transfer the loads from the sheeting boards to the cross braces by jointing the sheeting boards together. So ranger or walls, which basically these are nothing but the intermediate sections that transfer the load from one component to the another one. The soft soil require more elaborate and closer timbering than that of the harder soils. So that is quite obvious. If it is hard soil, then it has its capacity to withhold itself and not let what I can say scaved inside that particular trench if it is a hard soil. But for a softer soil, we need to have much more lesser spacing of these timbers for safety purposes. In case of extremely soft and waterlogged soils, or in place where timber is not available, steel sheeting or watertight and durable are used. So here, in case of very soft soil and waterlogged soil, so at that point of time, the timber is not available. So steel can be used as a part of this particular timbering or a braces system. So in the next slide, let us see the figure and try to understand it. Okay, so these are nothing but the timbering. Okay, so this is the section of that. Okay, so imagine, so this is the depth. If it is more, then what will happen? So here there will be a sheet, here there will be a sheet, and these are nothing but the cross braces or crossbars which are there. So these crossbars, what they do is they make sure that they are providing a tensile forces to these edges, so that the amount of pressure or else the amount of force that it can withhold will be taken care of. And because of this, what will happen, there will be no danger of scaving in of this particular soil into the trench. The same thing if I just try to show it with a lengthwise, okay, the section what we have drawn here. So like this, these particular planks are there, so these are nothing but the planks which will be there, okay. And to these are the attachments. So at a frequent interval, basically we are going to have that particular aspect. So here I'll just read out these. These are vertical sheeting boards of 15 centimeter by 5 centimeters thick, placed side by side or with gaps touching the trench wall side. So these are touching these wall sides which are there. Now next one is this particular in between sections what we have. These are nothing but the horizontal wooden ranges running all through the length of the trench. So these are helping them to make sure that these particular blocks remain in their respective place. Okay, so this is how the timbering works. So ultimate aim of this timbering is what? To make sure that the depth of excavation what we are trying to maintain will not be scaving in, so that to help for the safety as well as a quick working of this particular sewer line arrangement. So next one is dewatering. Okay, this is the next step of that. So dewatering is required if the water level is quite high or if the sewer happens to be laid very deep. Okay, so whether the groundwater is at a higher level or the depth of excavation is more, at that time if the water is intruding into your trenches, then the dewatering is required. It removed by an open jointed drain constructed below the sewer trench, which discharges into an independent watercourse either by gravity or by pumping. So we can use the pumps or we can use the gravity based on the conditions which are going to be available. With that we can do the dewatering process. It's removed by pumping out the water from the sump constructed in the trench. It should be operated for 24 hours if the water keeps on flowing into the trench. It is removed by pumping out the water from the sump constructed in the trench. It basically we can construct a sump over there, and it should be operated for 24 hours if the water keeps on flowing into the trench. Dewatering is in sandy soils become enormous because of the water flow is large and the subsoil is sandy. Quicksand is also caused. So it is done by well pointing systems. Number of well points are installed by water jetting method along with the sides of the trench at suitable distance of 1.5 meters. All these well points are connected to a common header pipe which is connected to the pump. So basically here what they are trying to say is, in the next slide we'll just check out the figure, but here what they are trying to say is whenever the amount of water is more basically in sandy soil, okay, so at that point of time we can have a number of wells that can be drilled down surrounding these trenches, so that the groundwater can be diverted into those wells that are surrounding the trench, and in turn we can finish off the work with the trenches. So let us see that figure to understand it in a much better way. Okay, you can check out this. So this is two ways which are going to be there. One is you have your pit, okay, you have your pit, and here you have your sewer line which is already there. So you have your bed concrete and everything. Apart from that, beneath that we can prepare a small trench and we can have a perforated pipe over here, so that whatever the water is being stored on this upper part can be taken into this smaller pipe and it can be taken out to the disposal point, or it can be extracted from there. So whenever this we are providing a particular pipeline for the this particular groundwater to move in, then that will help us to dewater the entire trench. This is one way. Or we can have one more way where this is our sewer line, this is the trench what we have dug up, and instead of having this at the bottom we can provide this trenches or artificial trenches surrounding these trenches. Okay, so we can dig up these holes surrounding these, and we can basically by doing so what we usually do is, here we are excavating at a much lower depth than the bottom of the sewer. So at that point of time the water will have space to move in. Okay, so whenever the water gets collected here, it will be pumped out and it will be taken away. So whenever we start doing this pumping out system, at that point of time, the amount of water that is going to obstruct us for this construction of sewer lines or laying of sewer lines will be minimized. So again, this dewatering is one of the significant step of sewer laying if the groundwater is at a higher level or the depth of excavation is quite high. Now, the next step of that sewer laying is shaping the trench at the bottom to the correct level, because excavation is one part. So whenever you do this excavation practically, there will be lot of rough edges that are going to remain over there because of the practical difficulties. Now the next step will be to correct the level of bottom. It should be excavated equal to the bottom of the embedding concrete or to the invert level of the sewer. Okay, so invert level of the sewer indicates what? The bottom level of the sewer. So invert level is nothing but the bottommost level of the sewer line is called as invert level. The bottommost portion of the trench should be excavated carefully so as not to dug more than the required. Because if you dig more than the required, then the depth of bed concrete will increase, or in turn the cost of that particular project is going to increase. So that's why this depth or else the bottom level of this particular excavation needs to be maintained properly. Next, we have two vertical posts are first of all driven along the sides of the trench at the interval of 10 meter at all junctions and change points. Here you can check out two vertical posts are first of all driven along the sides of the trench at the interval of 10 meter at a junction and the change points. So why do we need these particular reference points? Is to because maintain that particular proper bottom leveling and the slope of those sewer lines, because ultimately our entire sewers will be transferring the sewage through the gravity only. So that's why the bottom slope needs to be maintained, and for that these particular 10-meter intervals, that particular level points will be marked out. The horizontal board snapping the entire width is now fixed on that post by means of nails and is called as side rail. The horizontal board spanning the entire width is now fixed on that post by means of nails and is called as side rail. The vertical pencil line is marked on the wooden board and the needle is fixed on that line. The vertical pencil line is marked on the wooden board and the needle is fixed on that line. The string is attached between the needle and produce a line in space and is used to measure the depth of foundation or invert level and embedded concrete. A boning rod or a traveler is used to measure the level at the bottom of the trench. So you can check out. So these are the practical ways with which we can actually make sure that the bottom level of that particular trench is at a correct level. So let us see the figure to understand this in detail. You can check out here. So basically these are nothing but the pegs. Okay, this is your sewer line, this is the bottom. Okay, this is the depth of excavation. So this is your bed concrete which is there, and now this is the offset which is additionally required for the placement of pipes. So here to check out this particular depth, okay, so what they can do is they can have these pegs, vertical posts which are there, and these will be connected to a particular mechanism and a particular horizontal shaft. And here directly with respect to this what I can say level which is marked, okay, from here we can basically check whether the depth of excavation for this particular bottom of the sewer or invert of the sewer is correct, and the bottom of the bed concrete whether it is correct. So this is how basically we can make sure that the trenching what we are doing is at the correct level. Also because of during the laying how much depth of bed concrete needs to be there at what point of time, along with the placement of sewers can be checked for its correctness through these particular methods. Now laying of sewers. After the bedding concrete has been laid in, the required alignment and levels, the sewer pipes are lowered down into the trenches. So once everything is done, the pipes are being lowered down into the trenches. Smaller pipes less than 40 centimeters dia can directly be handled by masons and their helpers. So whenever the diameter is less, the laborers themselves can handle and carry and insert those pipelines into the trenches. Larger pipes can be lowered by passing ropes around each end of the pipeline. For very large pipes, machines have to be used. The sewer pipelines are usually laid from the lowest point with their socket end facing the upstream so that the spigot end can be easily jointed. So that is, wherever you want to joint that particular section or a pipe, so that will be at a much higher level than the one which has been already jointed, okay, with respect to the previous pipe. So that's why it will be laid in that particular pattern. After joints are jointed, the jointing is done with the lead caulking or cement mortar as required. So this jointing method will vary from material to material. Okay, so what kind of materials you are using for the sievers, so based on that even the jointing method is going to be different. Next, during jointing care should be taken to see that the pipe lengths remain in true level and alignment, and do not get disturbed till the jointing material is hardened. So that is, once you lay the pipes, okay, even you need to make sure that till the joint whatever jointing method that you are going to use, so till that is foolproof or it is matured enough, till then there should not be any movement of the sewer pipelines which are there. So that will help us to make sure that the jointing or the correctness of that particular laying is done. You can check out these. So laying of sewers. So this is the bottommost layer what we have. This is the sewer invert line laid at the required gradient. So this is the ground level which is there, you can check out. Now these are nothing but the socket. So previously what I was talking about, okay, so these are nothing but one side there will be the large opening for the other pipe to get in for the locking system. Okay, so here we have these particular side rails which are available. Okay, so boning rod for this. Next we have string line parallel to the sewer line, and at A the height h above the sewer inward, that is at a specified height you are going to have all these marks done. So once you put up these, then what will happen is already the one which have been jointed up, so that will be what I can say laid at the bottom, and the point at which the joint is to be done will be at a higher elevation. So even though right now in this figure for this scanned picture the flow of sewer is basically in this direction, okay, even though it may look in the opposite direction, but the flow is in this way as you can see over here. Okay, now the last step for this laying of sewers will be the backfilling. So while backfilling the excavated earth, it should be laid equally on either side of the sewers, and it should be filled up in layers of 15 centimeters thick. Okay, so each layer should be properly watered, tampered and rammed. The reason behind this is because right now you might be seeing after construction of newly road or any CD, so usually the roads sometimes cave in. The reason behind that is, imagine this, okay, let us say this is a trench. Okay, this is a section of that. Okay, so here we have laid that pipe, and on top of that we have put that backfilling. If I don't provide this backfilling properly, and after that on top of that if I construct a road, imagine this. Okay, so in due course of time what may happen is water may infiltrate. Because of this particular soil which is already over here can get compressed, and because of this what will happen, there will not be any support for the road for this particular width or section. And because of this, whenever the additional or live load of vehicles will be added to this, there is a chance of this portion of that road to collapse inside. Okay, so that's why if we don't want such things to happen, then we need to make sure that we are going to provide proper layer by layer compaction of this soil that will be laid, and we are going to provide sufficient for that consolidation or compaction to take place, then the further processing will be done. So that's why even the backfilling is an important step. So even putting a soil is not enough, so you need to have a proper depth, and that's why this watering and tampering and ramming that they have mentioned here. The reason being what? There should not be any caving in the due course of time. Next, the earth filling above the crown of the sewer should be carefully carried out. So, again, if I randomly put a huge quantity of that soil suddenly into this particular trench, then based on the material of the sewer, so this may get damaged at that point of time only. So that's why whenever we backfill on top of these sewer lines, we need to make sure that proper care is taken to provide this uniform load on top of those sewer materials. Last point, after few months of exposure, when the top layer gets fully settled, the road pavements may be constructed. This will prevent subsidence and cracking. So just now what I have explained, so if you don't want any kind of sinkhole to be created, then you need to provide a lot of time for this soil to settle down. Then only the further construction on top of that is preferred. Okay, so this is regarding the backfilling of soil in the laying of sewers. Now, the test for sewers. So once the laying is done, the next part is going to be testing. So we have two types of tests that are going to be there. The first one is test for leakage or water test. So here sewers are tested to ensure no leakage in their joints. They are tested between the manhole to manhole under a test pressure of 1.5 meter of waterhead. That is, even though the sewers are not going to be under pressure, but to check the jointing quality and to prevent any of the leakages, they usually test these sewer lines from manhole to manhole, and the water pressure for that will be usually 1.5 meter of head of water. Lower end is plugged in and the water is allowed to flow through the upper end. The depth of water in the manhole is maintained to the testing head of about 1.5 meters. The sewer line is watched by moving along the trench and the joints with leaks and sweats and are repaired. So basically, if the one end is basically plugged in and the another through the another end, they are going to put the water and they are going to make sure that there are no leakages in terms of joints or even with the sewer materials. Now the second one is test for straightness of alignment or obstruction. So it is tested by placing a mirror at one end of the and the lamp at the other end. If the pipeline is straight, full circular light will be observed. If the pipe is not straight, it would be apparent and the mirror will also indicate any obstruction in the pipe. The obstruction in the pipe tested by inserting a smooth ball of diameter 13 mm less than the internal diameter of the sewer at the upper end of the sewer line. If no obstruction is there, the ball will roll down to the lower end. So basically for this test for straightness can be done in two ways. One is with respect to the placing a mirror and a light source. If from one end to the another end, if one end if we provide that particular light source and on other end if we provide the mirror, so then the same amount of or else that entire shape should be visible over here. If it is not, then basically we can say there is any difficulty, so that part can be rectified. Or a second one is we can use some balls, okay, of the size 13 mm less than the diameter of the pipe. So usually this is used for a smaller size pipes where imagine this is your sewer line, okay, and these are these particular rollers which are of 13 mm diameter less than the size of the pipes. So these will be rolled out from the top end and it will be allowed to move in and it will be collected at the bottom. So if this particular rollers will automatically come to the lower end, and if they are getting collected, then we can say there is no obstruction, and the particular pipe is having its straightness. But if because any debris are there, or because of any what I can say mishap or any other defective nature, if any obstructions are present, so at that point of time these rollers will not be coming up to the other part of it. So at that point of time, so whatever the rectification for a given section of pipeline can be done based on that. Okay, so this is with respect to the straightness or alignment or obstruction of that pipe testing.